Hey everyone, welcome back to the channel. Let's take a look at another Leetcode medium problem, container with most water. So you're given an integer array height of length n. So this is the array height containing n number of elements, and each element is represented by a vertical line. The task is find two lines that together with x-axis form a container such that the container contains the most water. So we need to figure out the maximum amount of area any 2 points in this array can produce. So in this example, this marked part in blue color gives us the maximum area of 49, and no 2 points other than that will give us such a high area. And how do we calculate the area between 2 points? Let's say we have 2 points here, 4 and 8, and these are the heights of these two lines respectively. And we have a distance between them of 9 meter because 10 minus 1 is 9. And we need to find the maximum water this can hold. And if I draw a rectangle like this is the maximum area of these 2 points. I cannot increase this area like this because water will start overflowing right here when it reaches more than 4. So the maximum height I can go with this is this much. So the formula for calculating the area would be this width into this length. So we are taking the minimum length here, 4 into 10 minus 1, which is 9, which will be 36. Similarly, in this example, we have 7, which is the length, and 8 minus 1, which is 7. That's the width. And 7 into 7 would give us 49. And that's the maximum area here. We will try solving this using two approaches. One is the brute force one, which is not so optimal because it has a time complexity of n square. Then we will take a look at the optimal approach, which we can solve using two pointer in O of n. So in brute force approach, we will have two loops. One is outer loop, which points to I, and the second is inner loop, which points to j. As I moves 1, j moves from 1 to 8. And when I moves here, j moves from 2 to 8, and so on. So j always points to 1 more than I, and as these pointers move, we will calculate the max area and compare to the previous max area and keep on updating them. So at each point, we will calculate the area formed by these 2 points and compare it to the maximum area. If this area is greater than the maximum area, we will update that. So let's take max area variable and assign it to 0 initially. We have I at 0 and j at 1 to begin with, and we get this area, length into width, which is 1 into 1. So maximum area would be 1. Let's move j pointer and we get this area now, 2 minus 0, 2 into 1, which would be 2, and that 2 is greater than already calculated max area, so we'll update that. And we continue this and fill out the max area for every combination, and at some point we reach this where I will be 1 and j will be pointing to 8, and we get this maximum area where the length will be 7 and the width will be 7 as well. So we get 7 into 7 is equal to 49. And we will compare with the existing areas. We would have calculated so many here, and 49 will be greater than all the areas calculated, and finally we'd return this number. The problem with this approach is j moves several times here for every one move of I. So that's why this is n square and it's not very efficient. It doesn't work for larger inputs. Let's say if we have a million inputs in array, and by the time we traverse everything with I and j pointers, loop within a loop, we get time exceeded. Let's write a code for this brute force approach. So I'll take max area and assign it to 0, and I'll take len is equal to height dot length. Height is the array we are given with, and we need the outer loop for I is equal to 0, I less than length, I plus plus, j is equal to I plus 1. We will start j pointer next to I, j less than length, with j we will go till end, j plus plus. So we will calculate the current area is equal to j pointer minus I pointer, that is the x-axis distance, which is width, into max dot min, whichever is minimum between these 2 points in height. So we will take that. So we will take height of I, height of j. So we get the current area, and we will compare that with max area. So if max area is already greater, and will not change it. If not, we will update our current area with max area. So we see if max area or our current area is greater and update max area accordingly. And once we are outside the loop, we will return max area. And we'll code this in Leetcode and see how it doesn't work for certain inputs. And then we will talk about O of n approach. We have the same code here. Let's run this. And it's accepted for small input, but let's try to submit it. And we get time limit exceeded. Let's view all. This is a very large input. You can see at the scroll bar here. So O of n square doesn't work for this, because it's loop within a loop, and by the time it runs every iteration, every combination, it times out. So we need a better approach. So let's look at O of n approach now. Okay, last time we saw we had 2 pointers, but a loop within a loop. So we did a brute force of traversing each and every element possible. But if you carefully observe, here that's not necessary. So we need 2 pointers for sure, but in one iteration, we can get the maximum area. Let's see how. So the motive is to get the maximum distance between these 2 points and also making sure the heights are maximum possible. So to begin with, we will place our pointer at the beginning and at the end, and I've taken A and B pointers here and I've placed it at the beginning and the end to cover the maximum area possible. So let's see what the maximum area for this would be. We will initialize maximum area to 0 first, and now we calculate this white color part, that is the area. So the smallest between this height and this height is 1. So 1 into the distance between these two, 8 minus 0 is 8. So that would be 8, and I'll update the maximum area because 8 is greater than 0. Now which pointer should we move? Should we move A or B? The 0th index has got the smallest height between this and this pointer. So it would be better if we can move our A pointer further to gain the maximum possible area. Since we already have B pointer pointing to the maximum height when compared to A and B, we just leave our B right here and update A. So we'll move this to right. And now what's the area we are going to get with this? We get this area here. And this area is greater than what we already had calculated. So the length between these two will be 8 minus 1, which is 7. And smallest between these two would be 7. So 7 into 7, that is equal to 49. So let's update this, 49. Now this is the maximum area. Now which pointer should we update? Should we move A to right or B to left? So the height of A is 8 and the height of B is 7. So this is less. We don't want to move our highest pointer. So let's move our B pointer to left. And what's the area we are going to get now? We are going to get this part. So the white color part here, and we'll calculate the new area. 7 minus 1, which is 6, into the smallest number, which is 3. So 6 3s are 18. And this 18 is less than 49. So we will not update the max area. We will move our pointers. Which pointer should I move? A's height is more than B. So I'll just leave A as it is and I'll update B to see if I get more area. And this is the area I'll be getting now. 6 minus 1, which is 5, into both are same here. So 8. So 8 5s are 40. And notice 40 is still less than 49. So I'll not update the area. Let's move further. Now both the pointers have the same height, 8 and 8. Which one should I update? I can choose to update any one pointer in this case. I will choose to move my B to the left, keeping the A as it is. Now we will check what's the area. The new area would be this one. That is 5 minus 1, 4. And the minimum here is 4. So we get 16. 4 4s are 16. And 16 is less than 49. So I'll not update the max area. Since 4 is less, let's move the B pointer this side now. And the area we are going to get is this one. That is 4 minus 1 is equal to 3. And the smallest one is 5. So 3 into 5 is equal to 15. And 15 is not less than 49. Sorry, 15 is less than 49. So I'll not update 49. I'll keep the max area as it is. Let's continue this process further. We'll move this because that's of less height when compared to A, and this would be our new area. 3 minus 1 is equal to 2 times 2. So 2 into 2 is equal to 4. This is not greater than 49, so I'll just keep it as it is. This is the lesser pointer, so I'll move this further to left, and the area we are going to get is this one. 2 minus 1 is 1 into this height, 6. So 1 into 6 is 6. 6 is definitely less than 49, so I'll not update the max area. And this is the end because we don't have to move this pointer further, as that won't be a rectangle anymore. So we can stop at this point when a is less than b. So we will run this in a while loop, and we keep updating the pointers within this loop. If b crosses a, or if both b and a point to the same thing, then we can exit the while loop. And you see we got the maximum area 49, which is the right output we need to return. So let's write a pseudocode for this now. So we'll take a is equal to 0 and b is equal to height, which is the array, dot length minus 1. Initially b was pointing to this one, which is height dot length minus 1. So height dot length is 9, so we point to 8, so that's why height dot length minus 1. We initially take max area to be 0, we'll later update this as we go. And while a less than b, we need to calculate the current area, compare that with the existing max area, and if current area is greater than the max area, we need to update that. And we need to do this as long as a is less than b. So let's do that. Current area is equal to b minus a. This is similar to how we took in our brute force approach, into math.max of height of a comma height of b. We update the max area with the greater number. We check if current area is greater than the max area. We set max area to the current area, otherwise we set max area to the max area itself. And once we calculate the area, now it's time to update the pointers. So how do we do that? We need to pick the lowest height and move that to right or left. So if height of a is less than height of b, meaning if the left pointer's height is less, then we need to update that to right. So we will do a plus plus. Else, if b is less than a, or if b is equal to a in height, then we will do b minus minus. We will move our b pointer to left. And once we reach a equal to b or a greater than b, we complete this while loop and we return max area. So this is the pseudocode. Let's execute this in Leetcode and see if it works. So we are back on Leetcode. I've already written the code to save some time. Let's run this code and see. It's accepted. Let's submit it, and it works. So that was a two-pointer approach, how we could solve this problem. Thanks for watching. See you in the next video.